The first application of a hygen principle is laws of reflection. Here we know that the laws of the reflections are, that is, incident ray, normal, and the reflected ray all lie in the same plane, and angle of incidence is equal to angle of reflection. So these are the two laws of reflection. To verify, I first of all draw this diagram. This is our reflecting surface and a beam of a light which is falling obliquely on this reflecting surface. I will talk this in terms of wavefronts because I want to use hygen principle. So I suppose this is our wavefront. Wavefront is always perpendicular to the direction of propagation of light. जिस डायरेक्शन में लाइट ट्रैवल करती है उसके परपेंडिकुलर डायरेक्शन में वेवफ्रंट होता है. So as a ray propagate, this is our wavefront. At this point of time, when the wavefront was here, strike this reflecting surface. So at this point of time, I consider this A and this is our B. This is our incident wavefront because at this point of time, from here the light may reflect back. यहाँ से light reflect back हो सकती है. तो this is our last. I take AB as a incident wavefront. Now we know that according to the hygen principle, each and every point on this incident wavefront act as a source for the secondary disturbance, and the disturbance is carried in the form of wavelengths. अगर मैं मान लेता हूं इस B point से, this is our B point, I draw a line, this is our incident wavefront. अगर मैं मान लेता हूं B से C तक पहुंचने में वेव को या लाइट को it takes a tau time, then this BC distance will be how much? Velocity multiplied by time. So this distance, BC distance, this distance will be equal to B, velocity of a light in that particular medium, and tau is the time. To draw the wavelets, to draw the wavefronts at a later time, we draw the wavelets of radius v tau at each and every point on the incident wavefront. So if I draw the wavelets, I suppose I draw the two wavelets, one is this much, another is from here. So if I draw the tangent to these wavelets, the tangent to these wavelets represents our reflecting wavefront. And if I take this point as a D, then this DC will be our reflecting wavefront. So the light emerges out perpendicular to this wavefront. The light will emerge out along this perpendicular direction. That is this much. If I draw with a different color, so this is our DC. This is our reflecting wavefront. And the light emerges out perpendicularly along this direction. So this is our reflecting light. So this is our reflecting wave. AB is our incident wavefront and DC is our reflecting wave. If you want to see here, this is our incident wavefront. If you want to see, this is ये हमारा incident wavefront है AB. जैसे जैसे लाइट B से आगे बढ़ेगी तो यहाँ से लाइट क्या होगी? रिफ्लेक्ट बैक हो जाएगी. तो जैसे जैसे ये आगे बढ़ेगी, it will be reflected back. तो जैसे ये C तक पहुंचेगी, it has traveled to this much distance. So same it is coming out to be same. This stick represents the wavefront. Now it is a reflecting wavefront. Now I want to draw or want to verify laws of reflection. So first I will mark the angle of incidence. So I draw a normal to the surface. This angle is known as the angle of incidence, and this angle is known as the angle of reflected light. This is the angle of reflection. I represent it by R. According to this one, if this angle is I, then this angle will be also equal to I. If this angle is R, then this angle will also be equal to R. Why? Because angle made by the lines and and their perpendiculars are always equal. अगर दो लाइनों के बीच में एंगल और इनके परपेंडिकुलर के बीच में ड्रॉ करो, दिस इज द परपेंडिकुलर टू दिस वन एंड दिस इज द परपेंडिकुलर टू दिस वन, ये एंगल will be equal to this angle. So angle made by the two lines and their perpendiculars are always equal. See here, I'm having, so this is our angle of incidence is this much. तो इस लाइन के परपेंडिकुलर कौन सी लाइन है? This one. और इस लाइन के परपेंडिकुलर कौन सी लाइन है? It will be wave front, that is AB. So this is the angle of incidence. Similarly, this is our ray, reflected ray, and इसका reflected wave front कौन सा है? This is along this direction. And normal कौन सा है? Normal वाली लाइन कौन सी है? इसके perpendicular कौन सी लाइन है? This is this much, and the angle is reflected, our angle of reflection. So this is your this much. Now I want to verify this angle of incidence is equal to angle of reflection. To do that, I use two triangles here, triangle ABC and triangle ADC. So in these two triangles, I want to see here angle, here AC side is equal to AC because both the sides are equal. I want to see this ABC and ADC. So AC is equal to AC. Second one is that AB, this was our AB was incident wavefront. So I have drawn the wavelets at point B and at point A. At point B, I have drawn the wavelet of radius B top. तो यहाँ पर भी V top का wavelet ड्रॉ किया और यहाँ पर भी मैंने V top उतने ही रेडियस का wavelet ड्रॉ किया. तो इसका मतलब ये अगर मैं दोनों में, इसका मतलब ये डिस्टेंस कितना होगा? उतना ही है जितना BC के बराबर है. That is equal to V top. So I draw the tangent to these wavelets represents our reflecting wavefront. So here BC is equal to AD. So that is equal to V top. And further, angle ADC is equal to angle ABC. That is equal to 90 degree. See here, because we know that this is our incident ray. ये हमारी इंसिडेंट रे है और ये एंगल क्या होगा? 90 डिग्री. ये मेरी रिफ्लेक्टिंग रे है और ये कौन सा है? रिफ्लेक्टेड वेवफ्रंट. दोनों के बीच में एंगल होना चाहिए 90 डिग्री. So this is this much. So according to this property, these two triangles are congruent. So triangle ABC is congruent to triangle ADC. So each, अगर दोनों triangles congruent है, then every side and every angle must be equal. So this means that angle AC is equal to angle DCA. So from here you can see that angle of incidence is equal to angle of reflection. So this is your this much. So we have proved that angle of incidence is equal to angle of reflection by hygen principle. We on the same plane. अगर मेरा ये वेवफ्रंट जो है इस स्टिक में, इस प्लेन की, इस ब्लैकबोर्ड के प्लेन में है, तो मेरा रिफ्लेक्टेड वेव भी उसी प्लेन में होगा. ऐसा नहीं होगा कि मैं लाइट पड़ने के बाद, ठीक है ना, लाइट पड़ने के बाद, स्ट्राइक होने के बाद ये इधर को चला जाएगा, लाइट इधर को चली जाएगी. इट विल नॉट बी पॉसिबल केस. सो इफ योर परपेंडिकुलर और इंसिडेंट रे उसी लाइन में है, इसी लाइन में है, तुम्हारी रिफ्लेक्टेड वेव भी उसी प्लेन में रिफ्लेक्ट होगी जिस प्लेन में तुम्हारा इंसिडेंट रे है और नॉर्मल है, नॉर्मल टू द सरफेस. एंड